Hello and welcome back to Duncan Codes. My name is Duncan. Today we are continuing with part 5. We're on section 4, objects and references, and today we are going to finish the last few exercises. We're straight into an exercise. It's a two-parter called archive, and in this exercise you'll get to implement a program that can be used to handle an archive. Several items can be added to it. When no more items are added, all the items in archive are printed. The program should read items from the user. When all the items from the user have been read, the program prints information of each item. For each item, its identifier and name should be read. If the identifier or name is empty, the program stops asking for input and displays all information. So we've got the identifier, prompt with empty will stop. Got some inputs. I see. Okay, so the first one is the identifier, then the name, identifier, name, identifier. It's concatenated to print on one line. Okay, that's fine. Let's go to our TMC. Close down books. Let's open archive. Okay, so all we've really got at the moment is the main class. We're going to need some prompts and we're going to need some inputs. So let's start creating those. So let's grab that and we'll put that in a system out. I got rid of the double quotes. There we go. So we know that if it's empty, it will break. You also need to enter this as well. So let's grab that. And if it's going to be continually looping, we're going to need a scanner. So while, sorry, not a scanner, a while loop. So let's put that there. We are going to need to store the user input somewhere. So let's create some strings. We've got one called identifier, and we've got another called name. And then we can use those inside our while loop. So we can say identifier is equal to scanner dot next line. We'll need this as well for here, but it won't be identifier, it'll be name. We need an if statement to check for empty input as well. So if identifier dot is, oh, is it empty or blank? Let's do that one. If is empty, then we will use a break to exit the loop. And we'll need that for the other statement as well. But this one will be if name is empty. There we go. Let's just select this and align it all nicely. And what to do now? So we need to prepare a printout as well. Item identifier. Go and printing format. The printing format of the item should be identifier and name, and don't print the colon anywhere else in the output of the program. Okay, so we're going to need to add this actually to a list, aren't we, of some sort? So let's create an array list. We can have that as a type string and say that is equal to new array list, like so. So still here, we'll need to add these bits to the list. And say items.add. We will be adding identifier. And that is going to have colon, space, and then a bit more concatenation with the name. There we go. So it's the end of our loop. Let's put a for each in as well, and we can see what's being saved. So let's put it in as we see it here. We've got items, and then we're going to say for item in items, system out item, should be of type string. Let's give that a run and see what we get. Interesting. So it actually stopped before I expected it to. So let's just test that again. It might be because I was copying and pasting. Okay, yeah, it was. Here we go. Perfect. I say that. We haven't actually properly tested it yet. Let's actually run it and see what we get back. It being a two-parter. Oh, there we go. So we passed the first bit. That's good. So the second part, you only print once per item. Modify the program so that after entering the items, each item is printed at most once. Two items should be considered the same if their identifiers are the same. There could be variation of their names in different countries, for instance. If the user enters the same item multiple times, the print uses the item that was added first. Smart to add each item to the list at most once. Okay, so if we're going to have to start doing comparisons, it would probably make sense for us to create the item as an object or a class. Then we can use the built-in methods to check for equality. let's create a new class. So right click up here, Java class, and we can call it item. And we can start to think about actually what will be in the item class. So we will definitely need some strings, and they will be the same as the ones that we wrote in the main class. So we'll need a string identifier and private string name. Constructor. Yes, we do need a constructor. So when we initialize the object, we'll pass those details through, and then they can be stored in our list. So we are going to say string identifier and string name. We're going to say this dot identifier equals identifier, and this dot name equals name. And then let's head back to our main class, see if we can update this. So this is going to be, instead of being of type string, it's going to be of type item. And here, do there. So there we are going to initialize a new copy of our object to be added to the list. So let us write item equals new item, and we're going to pass the variables identifier and name. We need to check the list to make sure that this is the only occurrence of the item. So let's write our if statement to check our list. So our list is called items, and we're going to say dot contains, and it's going to be item. Then we can continue. Else, so the else is if they're not in there, we can say that items dot add item. So, and then we need to update our for loop, don't we? So remember we updated the data type from string to item, so we need to do the same here. So for item in items, print out items. If we run this now, have a think about what will print out here. There you go. So we get the class name and the hash code of the object. So if you realized that we need to add in the toString, then hats off to you, well done. So let's add that in there now. And remember, our printout is quite specific, isn't it? We're going to need to get rid of most of this. So let's get rid of that, and we are going to write this dot identifier. We need the colon in there, and we are also going to return this dot name as well. So that's looking good. Let's give that a run. Just had a couple. Okay, so we get our results. That's good. We've still got our yeah, that is also good. So now we can begin to consider our check for equality. So now we can go make sure I'm in the class, and we can have a look at adding in the comparison. So let's press Alt and Insert, and then go to equals. Equals and hash code. We only want the equals. Let's add those in then. So what have we got here? So we only want the equals one adding in. So we can select both of those, or select all. Let's get that selected. There we go, generate that. And so that's popped the hash code in, but we don't need that. So let's remove that. And now let's have a look for the equals override and see what we've got. Right, so I'm going to select and remove that, and then rewrite in what we need specifically. So let's do that. So we need to do a compare for instance of. So it was not compared instance of, and it's going to be of type item. Compared, that's going to be object. Object is not instance of item. We're going to return false. And lastly, we need to pass it, don't we? So item, so let's just call it temp. Terrible name. is equal to item, so this is the pass of the object, return this dot identifier dot equals temp dot identifier, so we're using the member variables now, and that should be it. So actually what we'll also need to do is check the comparison, won't we? Actually, if I want to use this, I'll need to add in another constructor, won't I? So public item, it'll be string identifier, say this identifier, comma, let's give that a run and see what we get back. We passed it, excellent. Bro. Yeah, let's give that a refresh. Perfect. Object as a method's return value. This will be quite interesting. We've seen methods return Boolean values, numbers, and strings. Easy to guess, a method can return an object of any type. In the next example, we present a simple counter that has a method, clone. The method can be used to create a clone of the counter, i.e. a new counter object that has the same value at the time of its creation as the counter that is being cloned. So we've got our class set up, we've got one member variable or encapsulated variable here, we've got two constructors, or a method for increasing, a toString, then the counter clone here at the bottom, and you can see that they're returning a copy of the object. Here we've got our creation of the object. We're calling counter increase. That will add 1 to the value. We've got print 2. Then we're cloning the object, printing them out to see that they are actually both the same at the moment. Then we're increasing the counter, and then you can see actually that they're the same object, but they're printing out different amounts. Immediately after the cloning operation, the values contained by the clone and cloned object are the same. However, they are two different objects, so increasing the value of one counter does not affect the value of another in any way. Similarly, a factory object could also be used to create and return new car objects. Below is a sketch of the outline of the factory. Factory also knows the names of the cars created. So private string make, we've got public factory, and then we're creating the cars here with the constructor. With the exercise base, the class simple date is supplied. The date is stored with the help of the object variables year, month, and day. In this exercise set, we will expand this class. Implement the method public void advance that moves the date by 1 day. In this exercise, we assume that each month has 30 days. In certain situations, you need to change the values of month and year, okay? So let's close down this one. There we go, so that's closed. And let's see, oh, it's dating up. Let's get that one open. Eventually. Let's see what we've got in here. So we've got our main and then our simple date class, which has got some bits and pieces in it, okay? So let's reread the challenge. So in this exercise, we assume that each month is 30 days. Implement a method public void advance that moves the date by 1 day. Okay, cool. So let's do our GitHub quickly. Let's get the file location, open bash. And the first thing we need to do is cd for change directory. So let's paste that in. Oh, get rid of that last bit there. Ah, that is because I've left the backward slash on there. Let's try that again. So let's get rid of that. There we go. Perfect. So now we're in the right directory. So we can do git add, and oh, it must have downloaded a lot new exercises. Let's do the commit then. So git commit completed. What was it? Exercise. Oh, part 5, exercise 15. There we go. And then let's push that. So git push u, origin, and then master. Done. Right. So we need to create an advanced class, the advanced method. And so let's go over here and look at putting that in. So public void advance and our curly braces. So we're just advancing the day. So what we can do is, let's just have a quick look and see if there's anything later on in the challenge about updating it more than one day. Oh cool, so we're going to be building on this method, so we may well go back and change it. So at the moment we just need to do this dot day, and then we can do plus plus, or you can do plus equals 1, whichever you prefer. Let's just give that a run and see if that passes any of the tests. It does, that's good. So let's have a look. So let's implement the method again, and then because we've got a different parameters being passed, it counts as a different method signature. So as long as you have a different amount of arguments, and you can have as many of the same named methods as you wish. So let's write this out first, so we can say this dot day plus equals how many days. Let's give that a quick test. I've got a failure there. Let's have a little look and see what that's saying, and see if we can figure out where we've gone wrong, or where I've gone wrong, sorry. Let's just have a read of that again, because there was some bits that failed. In certain situations you need to change the values of the month and the year, of course. So if we're working on the assumption that there are a certain amount of days in the month, so when we get to 30 we need to put an additional statement in, don't we? Another conditional. So let's just have a look at this again. So it says when you create an object on the 30th of the 12th and call the method advanced, the date should be the 1st of the 1st 2012. So yes, we need to put some conditional logic in there that checks for end of month and end of year. Okay, so let's put that in. If this dot day is greater than 30, we will do this dot month plus plus, and then would need to this dot days is equal to 0 again. Not 0. Oops, get rid of that s. We can do this dot day equals this dot day minus 30. So let's add the possibility to advance time to the simple date class. Create the method public simple date after number of days. It creates a new simple date object whose date is the specified number of days greater than the object the method was called on. You may still assume that each month has 30 days. Notice that the old date object must remain unchanged. Okay. So let's put another if in, and then we can say if this dot month is greater than 12, so this one is going to be for months and years rather than days and months. So this dot year plus plus, and then this dot month we can reset to 1 like that. So there's a couple of different ways of doing it. So let's give that a test. On the last run we got 44, and this time we've got 56, so we're definitely making progress and stepping in the right direction. So let's have a look and see what else we've got to do. So let's add the possibility to advance time to the simple date class. Right, let's have a look at this third part. Let's create the possibility to advance time to the simple date class. Create a method, public simple date, After number of days, int days for the class, it creates a new simple date object whose date is the specified number greater than the object that the method was called on. You may still assume that each month is 30 days. Notice that the old date object must remain unchanged. Since the method must create a new object, the structure of the code should be somewhat similar to this. So we're going to create the method, which is public simple date after number of days, and we're going to pass int days, and we're going to return new date. So we need to create the new date object, or initialize it. So simple date new date equals new simple date, and if we are going to increase the new date, then we'll need to do. So we'll need to give it some values. So it's expecting some data from us. So let's sort that out. There we go. So we've done our object, got our date here. See now, so now we can do new date dot advance, which is our advanced thingy from earlier, but we will pass the amount of days. There you go. So it's already selected it for us. Let's give that a run locally and see what we get. It was 56 last time, 78. Okay. So the error is that this method isn't advancing as it should. So this one's got all of the if statements in it, and this one doesn't. So to resolve that, because this is only going to increase by 1, what we could actually do is call the advanced method and pass the value on. So let's see what we get there. And then that will make sure that the days and the months are checked and correct. Okay, excellent. That's another one done. So let's update our GitHub as well. So we can do git add. So let's do our commit. So we completed part 5, exercise 16, and we can do the git push u. Okay, so looks like that's the last one. In the payment card exercise, we used a double type object variable to store the amount of money. In real applications, this is not the approach you want to take, since, as we have seen, calculating with doubles is not exact. A more reasonable way to handle amounts of money is to create an own class for that purpose, and here's a layout for that class. Interestingly, that note about the doubles actually came up on a recent job interview I had, and I had to explain why doubles aren't used for exact measurements. And I've got quite a good link as to why you should use big decimal over double, which I'll post in the comments below. Okay, so here we can see we've got our basic layout for our class. So we've got public class money, we've got 2 instance or field variables, we've got 1 constructor. We know it's a constructor because it's the same name as the class, including the capital M. We are passing 2 variables, so the 2 field variables that we've got here. We have a getter for euros and a getter for cents as well, and then we've got a toString here at the bottom. The word final is used in a definition of object variable catches the attention. Actually, I didn't even realize. The result of this word is that the values of these object variables cannot be modified after they have been set in the constructor. So once we've created this object, once we do money name equals new money and we pass in the 2 variables, we can't change the value of those 2 variables. The objects of money class are unchangeable, so immutable. You might have heard things are immutable or mutable. Immutable means that they can't be changed, and mutable means that they can be changed. So if we want to increase the amount of money, we must create a new object to represent that new amount of money. Next, we'll create a few operations for processing money. So our first part is plus. First, create the method public money plus, and we're going to pass type money, and it's going to be called addition, and it's going to return a new money object that is worth the total amount of the object whose method was called and the object that is received as the parameter. Okay, so we're just adding the value to an existing object. Right, let's find the correct project. There we go, and we've got our default package with the main program and the money class. So just as a reminder, we need to create a new object which takes on the new value and adds on the current value, and that actually is, it's going to be the same as this. So if you do get stuck, you've got this as reference. We can write that out and we shouldn't have any problems. So let's start by adding in the new method here. So we've got public money plus, so we can head across to our money class and we can add that in. So I'm going to put mine just below the constructor. And remember, the green on the left shows that there's new changes that we're making to the file that haven't yet been added to our Git project, so they're not being tracked yet, which is fine. So we have got public money and then plus. We're going to pass a type of money and we're going to call it plus. There we go. And oh, was it plus or was it addition? Must be addition. There we go. Oh, it was plus. And now we can add in some extra variables because we're going to need to store some additional information. So we've got total cents, and we're going to say that that is equal to this dot cents, which is the field variable. So you can just see on line 5 that that's highlighted up here. So you can see those two are highlighted. And what we're going to do is add some extra money to that. So here, this is a money object. In this parameter, we've got access to euros and cents. So if I type out plus and then put a full stop in, you can see what I mean. So here we have access to the field variables, so cents and euros. And then here you can see that we've got access to two methods, which are euros and cents. Okay, so I'll just put that in again. And what we're going to do is add cents there. And then we're going to do the same again, and that's going to be for euros. So total euros, and that's going to be equal to this dot euros, and then again we're going to add in plus dot euros like that. Forgive my typing, my microphone's in front of my keyboard, and although I can touch type, it's sort of in the way a bit, so it's pushing my hands out the way, so sorry about that. We're going to need a bit of conditional logic in here, I imagine, as well, to update, just like we did with the months and days, but as soon as we hit 100 cents, we're going to need to reset that back to 0 and then add 1 to the euros. So let's just see if there is anything in there about that. The basis for the method is the following. So they're saying they want us to create a new object. That is fine, and that actually kind of leads on to why we've got this error here. So you may have spotted that we haven't used the type void. So here, because we've used a data type, and this data type, reference type called money, we need to add in a return type, and what we're going to return is the new money account. So we're going to say money, and we can call it new money or just money, whatever you want to call it, is equal to new money. So we're just creating the object from the class. So remember, this on the left is the class, this is the object name, and then this is the constructor. And you notice that we've got an error, and you can see that it says it requires int on the second line down there, and that's because if we look back up at the constructor, it needs euros and it needs cents as well. So the euros and cents that we're going to be giving it are here. So actually what we need to do is take that and put it below here so that there's a bit of a flow to it. So now what we can do is pass total euros because the order does matter. So we've got euros and then cents, so we couldn't do cents and then euros. And then we're also going to pass in total cents as well. Okay, so at the moment you'll see that the new money is grayed out, so yours might be a different color, it might have a yellow underline, and that basically means that we've got this object and we're just not using it, and that's fine, we are going to use it. So when I type in new money here, that will disappear, that underline will disappear, and the error will go away as well. So there we go. So we've got a method signature, and the data type, or the return value for that, is the class money. And we've created an object of that class. So here, remember, this is the class, this is the object, and this is the constructor. And we're returning the new money object. In fact, what I'll do is I'll call that new money object, just to make it a bit easier to differentiate as well. Oh, no, I won't. I've been using, why am I not highlighting? Well, that's weird. I've been using Eclipse for work, and oh, it's got multi-select on. Why is that doing that? So my I'm a bit out of touch with my shortcuts. So it is it Control and F3 to rename? No, it's not. What is it? Control and R? Control and R. So new money, and we're going to say new money obj, and that's the object. And then I'll just put some comments on. So this bit is the class. There we go. This is the object, and this is the constructor. I don't know if that helps anybody, but it's there just in case. So we've done that. It doesn't say anything about having to add in sort of a condition to check if the amount of cents sort of ticks over to a new euro, but we'll give it a run and see what we get back, and I'm sure it will tell us in the feedback. So I'm not expecting much to pass. Oh my gosh, we got 50%. That's surprising. In the class money, create the method public boolean less than. Oh, that's fine. So that must be the next bit. So here we go. Here's the less than bit. Okay. Let's just see what these comments say. So we've got 10, 5, and 15, which we know because they're created here. A new money object is created and placed at the end of the strand connected to an old 10 euros at the beginning. Blah, blah, blah. Okay, that's fine. And then just here, all they're doing is printing out the value of the class. Sorry, not the class, the objects. So they're printing the objects here. Create the method public boolean less than, and then we're going to pass it a money object, and this one's going to be called compared, which returns true if the money object on which the method is called on has a lesser value than the money object given as a parameter. Okay, that's fine. So whereas in part 1 the return type was money, in this one it's going to be boolean, and remember boolean is just true or false, so quite nice and straightforward. So I'm just going to come down here and add that in. So it's going to be public boolean, and then it was called less than, and we need to let it know what arguments to take. So money compared, and then like I said before, this is another object just with a different name. When we're creating our method signatures, we can call our objects here whatever we want. In fact, any of the arguments or variables, they can be called literally anything as long as it conforms with the Java conventions. So you could call it money123 or whatever you want. So you can see again that it's expecting a return type. So what I've been doing is returning null. Because this is a boolean, we can't return that. We only have the option of true or false. But the reason I've been putting null in is until I have figured out the contents of the method, I'm not 100% sure of exactly what it is I'm going to return all the time. So sometimes it could be a string, it could be a JSON, it really depends what you need that method to do. So putting null at the start is absolutely fine, perfectly acceptable, just as like a default value until you figure out exactly what it is that you want that method to be able to do. So we have got to do some comparisons. So we are going to be using a conditional statement or an if statement. Some people call, I was going to write conditional there, some people call if statements branching statements as well because they help you branch through your program, but whatever you want to call them, we are going to use one of them. So we are going to say if this dot euros is less than, and we're going to compare it to compared euros, we are going to return true. And we can add another if statement in. Do we need to add another one? Create the when it returns true if the money on the object is called less value. These seem too easy. This doesn't seem as challenging as the previous one. Create the method public boolean less than that returns true if the money on which it is called has a lesser value than the money object given as a parameter. Well, this potentially will work because a return statement will break out of a method. It basically marks the last line of a method. So when we call the method, if it goes into this conditional statement, it will evaluate this, and if it's true, it will then come to this line, see return true, and it will stop that method right here. It won't proceed onto these next line. Well, it'll proceed to this, but it won't proceed to these lines. If it comes here and it evaluates false, it will skip over this and then come down here to return false. And it's not unusual to have quite long methods with lots of conditionals in, returning true or false, or, well, not null if it's true or false, but returning lots of different sort of options depending on where the conditional logic takes the user or takes the program. Let's give that a run locally and just see what we get back. So we got 50 last time. What's going on? Oops. Okay, we're still on 50, that's fine. So let's have a look. So when money, first money object equals new money, second money object equals new money 150, and that one's 10. Third money object minus 3 and 5. First money object dot less than, second money object expected true but was false. Okay. I think I know what the problem is. So here on the error message it's saying the first object it was expecting true. Hang on, what was it expecting? Expected true but was false. That might be actually because I haven't allowed a comparison for the cents. So here we're only comparing euros. Let's get rid of that. So let's think. If we've got euros less than compared, so we're going to end up with two if statements, and that's absolutely fine. You could use an else if you want. So what we can do here is say if cents is less than compared cents. We could really use the methods for those rather than just the variables. We'll return true, else we'll return false. And that will probably need to be nested in another if actually. So this one will only need to be called if euros and compared euros are equal in value. So euros less than, sorry, equals compared dot euros. There we go, and then I'll just, oh gosh, what's the thing to format it all? There we go. So Control A to select it, and Alt, Shift, and F to auto format, and it did all my indentation for me. Let's give that a run and see what happens. Oh, 75%. That's great. So we're heading in the right direction. That is brilliant. So let's have a look at this third part then. Write the method public money minus, and then we've got money decreaser, that returns a new money object worth the difference of the object whose method was called and the object received as the parameter. If the difference would be negative, the worth of the created money object is set to 0. Here are examples of how the method works. Okay, that is great. So let's start writing this method out then. So it's going to be very similar to the plus one, although it's going to be the exact opposite. But we're going to start with a method signature that says public money. This one is going to be called minus, and we're going to pass in a money object called decreaser. And for now, we can just return null, and that should get rid of our little error. We need to create a money object. So we've got money. We can call it new money object, just like the one above. Equals new money. Okay, so we've created that. And just like before, we're actually going to need to do some math to be able to pass in the required parameters. So we are going to create two integers, so total euros and int total cents. And what are we going to do with those? So we're going to do the exact opposite, aren't we? So we're going to say equals this dot euros minus decreaser dot euros, and then on the next line it will be the same but for cents rather than euros. So this dot cents minus decreaser dot cents. Okay, and then what we can do is pass those variables, so total cents and total euros in here. Total cents and total euros, like that. And that should get rid of that error. Remember, it's got that underline, or it's grey because we haven't used it yet. We haven't done anything else with it. So let's have a think. So that's not quite exactly what we need it to do, but it's a good start. What we need to consider are the values and negative values particularly. So let us think. Okay, let's just write something out, have a bit of a play around with it and see what we get, what happens. So we've got total euros. That is going to be greater than or equal to 0. What will we do? We would then need to know the amount of cents. So if total cents is less than 0, we would need to update the value of total euros and say that that is equal to total euros minus 1. So we can do minus equals 1. And then we would say that total cents, what's going on? Total cents is going to be equal to total cents plus 100. So could we do plus equals 100 there? So we've got that, and then we could use an else here. So if it doesn't meet those criteria, the values must need to be returned as 0. We could do total euros equals 0 and total cents equals 0. So wherever the numbers fall within that conditional logic, total euros and total cents are being updated, so the values here when the object is created will be accurate. And then we need to return new money, so we can just copy that there. Okay, I will just give that another wee run. Just on the off chance, did I press run? Am I going to get told off for pressing it again? No. So 75%, still on 75. Okay, so money, first money object equals new money. We've got 10 and 2. Money, second object equals new money, 2 and 0. So expected 8, but was 0. Okay. So we're passing in these two objects. The first value is are the euros, and the second value are the cents. Let's just check. So all of this looks correct. So let's just have a look here. I've put these the wrong way around. That's definitely not going to be helping. And then total euros. Let's give that another wee run. Oh, we did it. Okay, let's open Bash as well. So let's OK that. There we go, let's get that, copy that out, go to our git bash, cd, and then insert. Remember, we need to get rid of these bits there. So, is it programming I? Oh, I forgot the other quote. Oh, I wonder if that will work. No. Right, so let's put a quote in there, go to the end and get rid of this bit. There we go, so now we're in the right place. I hope. We can do git add. Let's just do a git status just to, there, that's good. So status just shows us what we've modified, or what it's waiting to be committed. So now we can do a git commit, and the git commit will be completed part 5 exercise 17. Brilliant, let's do that, give that a push. Push you, there we go. Okay, and then it says remember to check your points from the board on the bottom right hand corner. So let's just double check we've got everything. Ooh, I missed a quiz. So hopefully you guys haven't missed a quiz. Oh, it might be this quiz. Great, well fill your quizzes in and I will absolutely see you next time, and quite soon I hope, part 6, and that is going to be objects, nested objects. So objects of objects, that sounds great. So until next time, remember that you can get me on Discord if you need. I've had a few people emailing me as well and sending me messages, which is absolutely fine. That's what I'm here for. While we're a small channel, I can absolutely help you and give you my time, and I'm more than happy to do that. But as always, and until next time, good luck and happy coding.